All right, calculus. For this continuation of lesson 6.1, we're going to get going here on this problem that we skipped over yesterday. What I'm going to show you guys today is how to solve a differential equation, which you actually already know how to do, and to find a particular solution. All right, particular solutions are for a specified ordered pair on the graph. So in this case, you're going to be finding that C value. All right, right here, if the directions say find a general solution, we're going to add the C onto the end of our integration when we're finished. And if it says particular, we're going to have to find C. So if we're going to take and integrate this right here, the idea is that you get y by itself. So we're going to integrate this on both sides. If we integrate dy, we're just going to get y. All right, let's go ahead and do the integration, which you guys already know how to do. So we added 1 divided by that exponent all the way down, and we have a plus c on the end. If the direction said, again, find a general solution, I would stop here. This one has this ordered pair attached. So my y is 1/2 when my x is 1. And I'm going to use that to find c. Let's see, that's 2.5, so 5/2 plus c. Subtract that over, I'll have -2. So y equals x to the third minus 1/2 x squared plus 2x minus 2. And there's your particular solution. All right, that doesn't seem so bad. So what we're going to do now is we're going to move past here and let's go on to these notes. So find your 6.2 notes, and you might not have a copy of these, so you probably don't. I don't think I left a copy for you. What you're going to do then is take notes over these slides, and if I go too fast, just pause me for a bit so you can get caught up. All right, this is the process. You're going to be, if you're given y prime, you're going to change it to dy over dx, and we're going to solve for dy over dx. To separate the variables, you can use multiplying and dividing only. We're going to integrate both sides, and then we're going to solve for y, and then find c only if they ask for a particular solution. All right, so the first thing, and I'll try to write small enough that it all fits. We're going to take this and write it as dy over dx. All right, the problem that we did earlier had dy on one side and everything on the right was in terms of x. This one is not like that. You're going to have to separate the variables. Again, you have to keep x on one side, y on the other side. So we only can achieve that by multiplying or dividing. So I'm going to start by multiplying both sides by 2y. And then multiply both sides by d of x, or dx. Okay, so we're good there. I can now integrate both sides. All right, if I integrate 2y, I get y squared. And then I'm going to integrate x to the 1/2, so 2/3 x to the 3/2 plus c. And there you go. So you can solve for y if you want to go from here. We'll talk more about that when we find particular solutions. But if you do solve for y, you're going to need the plus or minus out front. And there you go. Later, when we find a particular solution, we'll talk about which one of those square roots that we want to use for that particular solution. All right, for our next one, number 2, we're going to integrate both sides. Actually, no, we're not ready to do that. I jumped the gun. We're going to separate our variables first. So dy y equals negative x dx. And now we're ready to integrate. Okay, I'm going to multiply both sides by 2. Multiplying your constant by 2 doesn't change it. Now, again, it's perfectly fine to leave these answers with y squared for now. If you want to take the square root, you can. You don't have to do that. So it's okay to leave it that way. Okay. All right, so in 6.1, your notes, number 2, we are finding the particular solution for this equation right here, given that right there. So in 6.1, all you've done so far is you've made your slope field and you graphed what you thought, you sketched a graph of what you thought the curve could look like. So now we're going to go back to that example and we're going to actually write the original equation that passes through 0, 1. So what we're going to do is start by separating our variables. Let's see here. First I'm going to multiply both sides by dx. See, I'm going to have to divide by y. So basically I'm going to integrate 1 over y dy equals the integration of 2 dx. All right. The integration of 1 over y is the ln of y. And that's going to be 2x plus c. Okay. Let's see here. We're going to have to solve this for y, so this is where it gets kind of interesting. This is a logarithm base e, and so what we're going to have here, if you want to rewrite it this way, you might understand then what we're going to do. We're going to switch it to an exponential now, so it's going to be e raised to this exponent, 2x plus c, equals the absolute value of y. Okay. Now to solve that for y, you're going to have to put that plus or minus out there. Okay. You need the plus or minus because you're removing the absolute value bars. So this is a general solution. Okay. But we want a particular solution. So now what we're going to do is we're going to look at this curve going through 0, 1, and we're going to figure out the equation. So we start there actually with this right here. You start back here and plug in the ordered pair. Don't start down here. You don't want to do that. Okay, start up here before you solved it for y. Okay, so we're going to have the ln of y equals 2x plus c. All right, so 0 equals c. And now our equation is plus or minus e to the 2x plus 0. Okay, so once I find c, then I'm going to take that c and plug it in there. That's what I've done. And then you have to figure out which of the equations is going to be the one that models your curve. It's not going to be plus or minus e to the 2x. It's only going to be one of them. And so you have to figure out which one of these equations contains the ordered pair 0, 1. So if I plug in 0 for x, either here or here, which equation is going to give me 1 back for an answer? Well, it's this one. So our particular solution now is y equals e to the 2x. Okay, we're going to try this again with this next problem. But in order to keep my videos under 15 minutes, I'm going to stop recording this video and then start up again so we can try this one.